From 1776 to 1800, the average age of first marriage for a male in Western Europe was 28.9 years, with a standard deviation of 5.5 years. Assume the ages are normally distributed. The 55% of Western European males that were oldest when they were first married were older than what age? So once again, we're dealing with a non-standard normal distribution. So we'll get that nice bell curve. Okay, the mean here, the mean is 28.9 years. Right, that's the average age of first marriage. We want to know the 55% of Western European males that were oldest when they were first married were older than what age? So what we are asking for is a little bit different than some of the past examples. We're saying that we want to know what value here, what is the value here, what is the score here, so that the ages greater than it constitute 55% of the ages. Okay, so in the past, we started with a generalized distribution, and then we converted to a standard normal distribution, right, using the formula z equals x minus mu over sigma. And then we took that and found the probability using the p-norm function in R. But that's not what's going on here. We're not given the x value, right? This is the x value, and we don't know what it is. That's what we're looking for. This time, we are given the probability, right? We want to know what value, what is the value, so that there's a 55% chance that a randomly chosen individual will have an age bigger than this value, okay? So we are starting over here. This is our starting point here. We're starting with a probability. This is where we want to get to. So our answer will be over here. Okay, so we want to do this process in reverse. We want to do this process in reverse. So to go from probability to the z, we're going to use the q-norm function because we know the probability, we know the p. Okay, and that's going to give us our z value. And then once we have the z value, we can use a formula to find our x value. In fact, it's the same formula as the blue one above, but it's just rearranged. So if I rearrange it so that x is by itself, then I get x equals mu plus z sigma. Okay, so I'm going to perform the same it's the same idea, it's just going in reverse. So in this case, my probability, my p, we are told is 55%, so 0.55. So that's all we need to do to start off to find our z value. So we're going to use our q-norm function to find our z value. So if we go to our notebook, we will use q-norm. And we are told that the probability is 0.55. And lower tail, if we look at our picture, we want the values that are bigger. We want the upper tail shaded, right? Because we want the 55% of Western European males that were oldest when they were first married, that were older than what age? We want the older ones. That's going to be the bigger ones, the ones to the right. So that means lower tail will be false. We don't want the lower tail, we want the upper tail. Okay? So if we run that, we have our z value. There it is. The z-score with 55% of the area to its right is z equals negative 0.1257, about, rounding off. Okay? So let's copy and paste that. That's going to be our first answer here. So go to MyOpenMath, give the z-score, need to calculate the result. There's our z-score. Okay? Now again, if you knock off these digits, you'll probably be just fine. But just to be safe, best to copy and paste it all. Okay? So now that we have that, we need to know the probability. So that's going to be the other step. So we've done this first step, going from probability to the z-score. Now that we have the z-score, we need to go from the z-score to the x value. Okay? Using this formula. So we found the z, we need to find the mu, we need to find the sigma. Now those values are told us in the original problem, right? The mean is 28.9 years. So that's our mu. And our sigma, our standard deviation, is 5.5 years. So sigma equals 5.5 years. So to find the x, we'll do x equals mu plus z sigma, which will be, our mu is 28.9, plus our z, which was negative 0.1257 about, times our sigma of 5.5. Okay, so we're going to take that and we're going to throw that into the notebook. Okay, so that we could find what the x value is. So we're going to take 28.9 plus, and then you could either copy and paste the z value, or you could just round it off to a few decimal places. Just make sure you include enough. Okay, if in doubt, copy and paste. Okay, so if you aren't sure how many decimal places, just copy the whole thing and paste it in. So our mu plus our z value times our sigma, which is, if we look back at our notes here, our sigma was 5.5. Run that. There we have it. So what do we conclude? 55% of males from 1776 to 1800 were married after the age of 28.2 years. Where I got that 28.2 right here. So let's take this, copy it, let's throw it into MyOpenMath, submit, and we have it.